Hello, we're doing checkpoint 4.30. They want us to find the direction for which the directional derivative at -2, 3 is a maximum, and they want us to find the maximum value of the directional derivative. So it turns out that direction of maximum increase is actually the gradient, and so that's going to be a vector for us that we're going to find, but the actual maximum directional derivative is the magnitude of the gradient. So both of these facts, I think, are set as theorems in the textbook, and it can be proven. So all we have to do is find the directional derivative, or find the gradient at the point -2, 3. So let's find those pieces for the gradient f sub x. With respect to x, the first term is going to be 4, and then the second term is -y, and then the third term is 0. And we want to evaluate this at the point -2, 3. So let's put 3 in there. 4 minus 1 is 1. Next, we'll take the derivative with respect to y, and that will come out to be 0, and then a -x, and a positive 4y to the first power, and we want to evaluate this at -2, 3. So -2 in for x, this is going to be -2 with a negative outside. It's going to be +2. 2 plus 12, I think, is 14. And that is our answer for the first question. So the direction of maximum increase is equal to the gradient, which is equal to 1, 14. Okay, we can, if you want, make this into a unit vector, but we can just leave it like that. And then the other question they're asking is the maximum value. I'll say maximum directional derivative, and that's equal to the magnitude of the gradient, which is simply the square root of 1 squared plus 14 squared, and I believe 14 squared is 196. So let's say this whole thing is square root of 197. Okay, I think that's good. I hope that helps.